Whitman, you're muted.
Thank you. All right. Well, at least it didn't go the whole class. Like the last semester, didn't I have a thing where I never shared my screen one of the days? All right. Well, thank you. I'm not muted anymore, correct? You can hear me? All right. So, um, remember that scanner lives inside of the java.util. So I'll go ahead and grab it from where I put it in driver. We'll move it into our dungeon so we have access to that scanner. Remember, the scanner is the thing we're going to use to read something in from our user. So we have our scanner there. I'm also going to go ahead and grab our array list from here because we might take advantage of that. I'll go ahead and put that inside of dungeon as well. So out here in main now, main's pretty simple. Create a player, create a dungeon, and then ultimately I'm going to say the dungeon.play. That's all main's going to do. And play is going to do all the work for us. So now back in our dungeon, inside of play, what I want to do is I want it to keep asking us for a direction and then responding to it in some way. For right now, I'll just have it spit it back out to the screen so we can see it work. So we're going to system.out.print. What direction do you want to go? We'll say line is equal to input dot, what is it, next line? That. So that'll read in whatever they type. We're going to keep going as long as line dot equals maybe quit, as long as it's not equal to that. So as long as they didn't type in the word quit, we're going to keep asking them again and again and again and again. After they type it in right now, let's just go ahead and spit it back out just to prove we read it in. So all this thing's going to do right now is say what direction you want to go. We'll type something in, press enter. It'll spit back out to the screen whatever we typed in. And if we happen to type in quit, it'll leave the game. I'll just do a system.out.println goodbye down here. Good. Print doesn't press enter at the end of it. Println is like you typed it out and then pressed enter, so it kicks it down a line. So I'm making my prompt wait for you to type something in right next to it there rather than the next line. Purely visual. All right. So if you remember way back to when we first introduced loops, this might be the first time you've seen a do while loop in a long time. Remember, we introduced while loops and for loops and do while loops, and we said that while loops and for loops are very similar. They're both pre-check loops. That is, we check the Boolean expression associated with those loops at least one time before we even execute the body of the loop once. But in this case, we do need to ask the user for some information at least one time before we can make any decision about what we might want to do. So that's why we're going to do something. So this body of our loop does happen at least once. Then we ask, does whatever they entered in, is it something other than quit? If it's something other than quit, let's keep going. Presumably, we're going to be making them move around in our dungeon. But if they finally type in quit, then we'll fall past this while loop and we'll just print out goodbye. All right, so this is all that play does right now. It does nothing to do with rooms at this point. We're just doing some testing to make sure that we're at least prompting our user reasonably. So I'll go ahead and hit run. What direction do you want to go? I'll type in north. It just spits out that I wanted north. I'll type in east. Then I'll just type in quit, and it exits us out of that loop and says goodbye. All right, so we can feel confident that we have the interaction between the scanner and our user working out now. Now we just need to do something other than just spit the text out to the screen. All right. So what we want to have happen here is we want to show the user the room that they're currently in right off the bat and say, what do you want to do? And then if the user moves to a different room that was one of the obvious exits, we want to take them out of the current room, put them into the next room, show them the information about that room as well. All right, so now right off the bat, we have an issue. Inside of this function called play, I do not have access to any of these variables that live up here in my constructor. These are all local variables in my constructor. So what I probably want to do is create a couple of private fields that I can add these to so that I do have access to them inside of Dungeon, but in another function in there. All right. So at this point, if we look back at our constructor, we built 6 rooms and then we added a bunch of exits to them. Let's go ahead and load those 6 rooms into an array list. Maybe just keep that global so we have our rooms. All right. So I'm going to say private array list of room. Call this guy the rooms. This will be a new array list of room. So this is an empty storage container for us to put rooms in. And it handles all the work of, if we add 5 rooms to it, it adjusts its size as necessary. Go ahead. Okay. So we talked last time, this is kind of the updated, maybe we can view it as the upgraded quality of life version of an array. Under the hood, it's just as inefficient as using an array if we were to write it ourselves and have to keep track of how many things that were in there and things like that. It's just a convenience for us. Just as inefficient data storage wise, but also just as efficient speed wise, which is fast. Array lists would be fast. Next term, when you take the data structures course, coding 3, you'll learn about linked lists, even though we're kind of building one here with our room. So I think it'll make sense when I say they are more memory efficient, but they are slower because we effectively are going to have to walk through our dungeon by going from room to room to room to room. And each of those rooms live in a different place in memory. And we're just hopping by pointers to get to these different places in memory. All right, so I have all my rooms here. Well, I have a place to put my rooms. What I'll go ahead and do is at the end of my constructor here, I'll say this dot the rooms dot add R1, and I'll do that for all the other ones as well. So there's 6 of them, right? For 2, 3. Right. 6 rooms. We threw them into this array list up here. So now we would have access to those rooms if we needed them down here in play. Haven't quite opened the door yet to what we really want to do yet, but our rooms don't just die when the constructor's finished at this point. All right, now we're going to go ahead and decide if we go by our picture here, our dungeon looks like this. Maybe we decide the entrance to the dungeon is R1. So maybe for a dungeon, we also keep track of private room, the entrance. And then down here, we can say this dot the entrance is equal to R1. If that's the room we intend to be the entrance to our dungeon. We may or may not use that, but it seems reasonable that an instance of a dungeon object should know where that dungeon begins. Could be handy in the future. All right. Now we want to go ahead and get our player into that room. So if we go back and we remind ourselves what rooms have in it, remember a room keeps track of a potential player that's in the room. And we have a function here to set the player for a room where it sets that player as being in that room. All right. So we go back to, I'm going to just steal this here. Go back to our dungeon. Remember, we have our player right here. So after we've said what the entrance is, let's just go ahead and say this dot the entrance dot set the player to the player. And this dot the entrance is a synonym for just saying R1. So you can choose either one of those things. They both those variables point to the same place in memory. All right, so now the player lives inside of a specific room. What we're going to do now, we look at player. A player does not know about the room that they're currently in. I think I gave you a hint with the assignment that it might be handy to teach players to know the room they're standing in. So we'll go into player here and let's create a private room called maybe my current room, something like that. And we can start that off at null by default, even though that is the default value. And then what we'll do is we'll add a setter for us to set the room a player is currently in. Public void set the current room. Returns nothing. This is the return type for a function, as opposed to like is dead returned a Boolean, true or false. So set the current room. We're going to go ahead and say this dot my current room is equal to R. We're not doing any checking. We're just saying, hey, if somebody externally tells me to set the room to this, I'm just going to do it. Similarly, we might find it handy to be able to get at the value of that room. So public room get the current room. This would return this dot my current room. So the way to think about this is what we've just done is we've given some abilities to our players. A player now knows how to keep track through a field of what their current room is. And then we've given them some functions that allow us to externally set that value as well as externally get that value. Giving us the opportunity that if we did want to put some logic around setting it, we could. We're just not in this current case. All right, and I'm pointing that out because you might just say, well, why not just make it public? If you're just leaving it, I would say it's bad programming practice. Always make your fields private. And if you need to give access to them, do it through getters and setters. Most new languages have kind of built-in getter setter automation where when you define your field, you can put next to it what you want to make available and it'll just magically do it. A lot of IDEs, even before that existed, also had the thing where you could like right click on a field and just say generate getters and setters, and it would just create those functions for you. Quality of life things.
Just to remind me, it's like, what would be the biggest issues that could potentially happen if your fields are public? Just like accidentally changing them?
Okay, yeah. So the question for those of you online is what's the biggest problem with making your fields public? Yes, it's that you're giving full rewrite access to the field without any oversight. Now, in a situation like this, we haven't put in any oversight. So it would be very difficult for me to truly argue based on consequences that there's a difference. If we had made this public, it would function identically to what we've done right now. But making fields public typically is considered bad programming practice. because usually when you want to set the value for something, you would usually have some sort of logic around this. So like something like if R not equal to null, then we'll let them go ahead and set the room. So I guess the better thing to say would be that it's good programming practice to have some level of oversight to whoever is setting values of your fields from external outside of this class. Otherwise, they can just set it to whatever they want. If you're the only one programming it, though, it would be very difficult to make a true argument. Why not just make all public and make your life easier? It's less functions you have to write. But that would get you into maybe a bad habit, I guess is the punchline. All right. So players now know how to remember the current room they're in. Goes back to first week of coding 1. Languages allow us to remember stuff, ask questions, repetition. So we can now remember the room we're in. We have a way for external folks to set that room as long as they don't try to set it to nothing. And then we have a way for external folks to also get the current value of that room read-only. Okay, so we don't let them change it directly without some level of oversight. So what we'll do here is when I'm going to go to room. When we set a player for a room, that means this player was just added to this room. I also want to let that room or that player know about this room. We just wrote a function that allows us to set the current room for a player. So here we have the player. We just let this room know about the player. Now we're going to let the player know about the current room. How do we refer to the current room? I want to let the player know about the current room that we're in. How do I do that? Good. I'm in the room right now. We're inside room. How do if I'm room, how do I let this function know about myself? How do objects refer to themselves from within themselves? This. Just this. This is a room. It's kind of like saying me. So I'm saying, player, I want you to set your current room to me, to the room we're currently in, the room that you were just added to. All right, so this room just learned about the player and then let the player know about itself. All right, so this is those situations where understanding that this keyword becomes important, because that's how inside this instance of room it refers to itself. That's how the equivalent of a human being saying me. We say this. All right. Now, let's go ahead and go back to our dungeon here and add some stuff now into our play. So we know that the entrance has been set for whatever reason, but we have access to our player, and the player knows what room they're in. And rooms know how to display themselves to the screen. So we could say inside of our loop here, this dot the player dot get, what did I call get current room is probably what I called it. Get the current room. Dot display. And actually what I probably do is just do something like room temp is equal to this. And then tell that room to display itself. The reason I'm putting it in a variable is there's a pretty good chance if I'm in a room that has an exit to the north and we type in north, we're going to need to talk to that room about getting the player out of that one and getting it into the next one. So probably remembering it in a variable is going to be handy. If you remember, rooms do have a display function. So we're just asking that room to display all the information we've previously written about it. All right, so now what happens is every single time through this loop, the room the player currently is in displays itself. We don't have any logic yet that actually moves us out of that room, but we at least now know the room we're in. Forgot a semicolon. All right. So this is the current room, room 1, which was the dungeon entrance that we put the player into in the constructor. We do see that we're also here. Maybe that's a little bit weird, but we're not going to mess with that right now. We could maybe just say, don't say my name if I'm the one asking you to do it. Right now, we'll type in north with the expectation that we would take that exit to the north, even though right now we're not actually doing it. So it's just going to spin back around and show us the same room again. All right. But if we type quit, we get out of the thing. Yep. So we're making little baby steps towards where we want to be. Well, player came in to the constructor for dungeon. That was already happening. So we let the dungeon know about that player. We also decided to let the dungeon know about its entrance, even though we're not using that right now. And we went ahead and told the room, the entrance, so with that R1, told it that the player that's in that room is the player. Here, just for the sake of argument for right now, I'm going to dump the entrance because I'm not using it. And we're just going to say this. So R1 dot set player, we've just decided R1's the first room in our dungeon. We're going to set the player for R1 to whatever player was passed in here. We look at room. When the room sets the player, it remembers the player, but then it tells the player about itself. I might call this kind of the secret sauce for this assignment. That little piece right there, that handoff, where a room finds out about the player and the player also finds out about that room. And that deals with understanding this keyword. All right. This guy's still running. Okay. So now, down here in play, we're showing the room, we're reading in a direction into line. Rather than just spit it back out to the screen, what we want to do is we want to try to go in that direction. Maybe the first thing we do is we ask, is this a legal direction? Okay, and who might know about that? We think about rooms. Rooms keep a array of available exits, right? And we can look at this now that we understand array lists, we could have updated these to be array lists instead of arrays keeping track of it, but we'll leave them alone for right now. But in any case, every room knows about all of its exits. So we could add a function to a room saying public Boolean has exit, and maybe somebody passes in the direction. We're going to ask the room, do you have an exit in the direction that I'm potentially thinking about going? All right. So from a room's perspective, if we're asking, do you have an exit in this direction? What we're going to have to do is go through all of our exits. How do we do that? We say for int I is equal to 0. I is less than this dot current number of exits, not available exits dot length, because we may not have filled that entire thing up. If it was an array list, we wouldn't have to play that game. I plus plus. So this loop takes I on a voyage between all the legal indexes of our available exits. Let's look at an exit. An exit has a direction associated with it. It also has a function called get direction. So we can, for each direction we see, we can say, hey, or each exit we see, exit, what direction do you lead to? Does that equal the direction the player's trying to find out if it exists? If it does, return true. Otherwise, check the rest of the exits. If we never found any of them, return false. So we'll go ahead and say, if this dot available exits at bucket I, that is an exit. Dot get direction, that will boil down to these strings. This guy right here will boil down to the string representation of the direction associated with this instance of exit. It'll be that guy right there. And now we want to find out, does that match the exit that was passed in? We already have done that. We're already keeping track of the number of exits inside of room. Current number of exits. Let's look at the code that we had already done to do that. We'll come back because that's not something we just wrote. That's not part of what we are just writing now. So just assume that works for the moment. You can go back and look through how we kept track of that. Right now, we're trying to find out if I go through all my exits and I want to know if one of those exits already had the direction. We're going to say if the exit I'm currently looking at, when I get the direction, if that guy equals the direction I'm trying to go, return true. Now, if you want to make it a little bit more user-friendly, there is a version of equals for the string class. Remember, you don't want to use double equal sign when comparing strings. We don't want to say that. Why is that a bad idea when dealing with strings? It probably would actually work this time. But why is that a bad idea? We talked about it last semester, which I'm sure everybody memorized everything. This is another one of those super important concepts that at first glance doesn't seem like it'd be that important. What is the double equal sign? It's the Boolean equivalence operator, right? But for primitive types. Double equal sign is how we compare primitive types to each other in programming languages. That double equal sign only would let us compare non-primitive types to each other if the maker of the language built that into it, which Java does not have that built in. So that means if I try to say, is this string equivalent to this string, it is not checking the contents of the string. It's checking the memory address where it lives. Now, in both of these cases, since we've only used string literals like double quote, north, double quote, and we never said new string, the first time we create a string, double quote, north, double quote, it gets put up in memory somewhere. Every additional time we ever make that string, it still uses that same address. So for those of you who did use double equal sign on your assignment, you probably found it worked, but it worked for the wrong reason. It worked because you weren't comparing. I wasn't saying, does this string, maybe it says north, is it equivalent to this string, which also says north? It's not looking at contents. It's looking at memory address. So if we want to make sure it's comparing the contents of the string, regardless of where it happens to live, we have to use the equals method from the string class. The string has provided us a way for it to compare itself to other strings. To make life a little bit easier, there's also an equals ignore case function. If you go look at the documentation for strings, you'll find it in there. You could also convert the string to lowercase and convert the other one to lowercase and then check to see if they're equal to each other. all sorts of ways you can pull this off. But if you want to be case sensitive, just leave it as equals. All right, so remember, the function we're writing here, all this function's doing for a room is it allows somebody outside of this to ask, do you have an exit in this direction? So we're going to go through all of our exits. For each of those exits, we'll check to see if the direction is equivalent to the direction you told us to look for. If it is there, we'll return true. If after I have checked all my exits and I didn't find anything that matches the direction you put in, I'll return false. So now let's just see this little guy in action. We're not going to make any decisions based on it. Let's just see it happen. So what I'll do now back in Dungeon is after the user types in the direction they want to go, let's ask the question, if temp.hasExit line this is a legal exit. Else, ay, ay, ay. Where do you go? All right, so now they'll type in where they think they want to go. We'll ask the current room we're in if it has an exit in that direction. If it does, we'll say that is illegal. This is a legal exit. Otherwise, we'll say, where do you want to go? Presumably, if we're in here, that's where we would actually make a move, but we're not going to do that yet. So let's just see the sky function. We're testing that function we just wrote that allows a room to report to us whether an exit in a certain direction exists. All right, so we see the current room. If we type in west, we're gonna see that. Oh, sorry. If I type in west, why is it going so slow? It says, where do you want to go? If I type in north, notice it says this is a legal exit because this room did have an exit to the north. So it seems like that function we just wrote for a room to report whether or not it has an exit in a certain direction is working. So now that we can ask a room, do you have an exit? Now we probably want to have the ability to actually take that exit. So in room, we're going to build in a function. Remember, I have to type quit to get out. Otherwise, you can just kill it. So let's have a function called take exit that goes through and it finds the exit. Presumably, it's already decided whether or not that you've already pre-checked to see if that exit existed. We could actually put the logic in here. In fact, we might even do that. We might make this guy private and say that we're only going to allow a room to check within itself if there's an exit that exists. So then we can say if this dot has exit direction, only under those circumstances do we actually move the player. Otherwise, we do something like system.out.println no exit in direction So by making has exit private, that now means that we cannot access it out here. What's up? Ignore cases from the string class. It allows us to, let's see, in room, this compares this string That guy right there will boil down to a string that's going to be some direction. This guy right here is also a string leading to some direction. This compares those two, disregarding capitalization or anything like that. It's built into the string class. String class also, if you just want to have notes for it, if you ever need to do something alphabetically, there's a function called compare to in the string class. It actually isn't alphabetical. It's called lexigraphically. It's in order of the Unicode character set, which just happens to have the letters next to each other, so it will be alphabetical as well. But technically, things that like start with question marks would get sorted as well. But there's an ability. This is one of those things like, okay, I have two strings. I want to know which one comes before the other one. Let's see if the string class has anything to help me with that. So it has several functions like that. One of them is ignore case. All right, so we've made has exit private now, which means what we just wrote a second ago to test this, that's no longer going to work. We're asking the room if you have this exit. Well, that's private. So really what we want to do is we're going to say temp dot take exit. So we're in the middle of writing take exit right now. Has exit is private, but take exit is public, and this guy calls has exit. All right, so effectively from our dungeon perspective, when a player enters in a direction, we're just going to try to take that exit and let that function figure it out behind the scenes. It's going to check to make sure it's a legal exit, and if it is, it's going to actually move you. So back into room here, if we're into this if statement right here, that means that there is an exit in that direction. So we actually want to take the player out of the current room and put them into that new room. All right, so let's go and get that exit. So what I'm going to do is we'll just repeat the code. We probably could have done this a little bit cleaner, but just repeat it anyways. We know this exit will exist. So we're going to go through all of our exits, finding the exit that matches that direction. So same if statement we did there. If I found that exit, what am I going to do? I want to take the player out of that room. Now, rooms currently know how to add exits, or I'm sorry, add players, set the player for a room. But how do we take the player out of this room? Remember, this room is keeping track of a variable called the player. We want to add that to the destination room. When we look at exits, exits hold the room that is in the destination. It's private, so we need to give ourselves access to that. When we have the door, we have an exit, we can say, give me the room you lead to. We're going to now create a getter so we can hand you that room, and then we're going to add the player to that room. Then we'll remove him from my room. So we're going to say public room get destination room, return this dot destination. Steal that thing. We made that public. So now inside of room, once we have the correct exit, we'll say this dot available exits at bucket I get destination room. So this is an actual exit. We're going to ask that exit for its destination room, and then rooms have the ability to add a player, set the player for that room. Set player to this dot the player. So this is put the player into the destination room. Lastly, remove the player from this room. This dot the player equals none. And remember, when we set the player for that destination room, that's going to be a different instance of room, which not only lets that room know about the player, but updates the room the player's in. So the player gets they let the player know about the room they just went into. All right. Yep, thank you. We're done. I think this solves the homework right now. All right, so if we have the exit, we do all the work to go and get him out of this room and put him into that room. If we don't, we just spit out there isn't an exit in that direction and the player's room has not changed. The loop will spin back around and the player is going to always show the current room that they're currently in, whatever room that is, whether they changed rooms or stayed in the same room. So if I run this right now, see, this one matches, this one matches, this one matches. One, two, three, two, 1, 0. Oh, thank you. Thank you. This guy is returning. Actually, we don't even need to have a return statement. We don't need to tell them whether it worked or not. They'll find out the next time through the loop whether the room has changed. So now we should be able to walk around our dungeon. So I'm in room R1. I'll hit north. Now we're in R2. If I go back south, I'm back in R1. If I go north again and then go north again, I'm in R3. I can go west. I'm in R4. I can go east. I'm back in R3. East again. I'm in R5. West, then north. I'm in R6. South. 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 We're back in the main room. All right. So with all that, we are now able to walk around our dungeon. All right. So now, what would be the next thing that would make sense for our let's say our game, as we're able to walk around our dungeon now? Maybe to put other things in the game, like a rat or something like that, and have him move around in the dungeon and things like that. So what we'll do next class is we'll start writing that. So it's going to bring threads back into it, right? We're going to have our monsters controlled by threads, right? So we'll say create rat, put him in room 4, let's say, and then tell that rat to go. And what we'll probably do is something like maybe every 1 to 5 seconds or something like that, the rat will kind of like roll the dice to decide if it should leave that room or not. If it decides it should leave the room, then it'll randomly pick one of the available exits and leave the room. And then from everybody else's perspective, they would get to see that, oh, a rat just entered, something like that. Does that make some sense? All right, so what we'll do next class is we'll get the foundation for that started. And then you might have an assignment, a small assignment related to that for Friday to kind of get it across the finish line. And then we'll kind of get that working. Once we have that working, we have our threads kind of functioning and stuff, then we're going to start transitioning over to Unity, porting our Java dungeon over to a C# dungeon, which is going to just require us to make a couple of things lowercase instead of uppercase and stuff like that, because we're going to have our instance of our dungeon exist behind our video game. Right. So this is kind of the way it's going. We're not rewriting all this code. Not that there's that much code here, but once we get over to Unity, you're going to have kind of the visual portion of your game, which is going to look ugly, but it's not going to just be text-based. All right. And then behind the scenes, you're going to have the actual representation of your dungeon, which is what we're doing right here. Modern video games do this stuff. Just when you look at the current state of the dungeon, for example, you're not viewing it through a text-based interface like this. You're viewing the 3D graphics or whatever that makes whatever it's keeping track of behind the scenes true. So what we're writing here is usually referred to as the back end, right? In the back end of a video game, and Unity is going to allow us to start creating maybe a more interesting front end, not necessarily better looking, but an interesting front end that still leverages the exact same back end programming concepts we're dealing with there. All right. I'll put up a link to the current code so you can check it out, make sure you understand what it's doing. Questions, comments, concerns, bribes. All right. I will see everybody on Wednesday.
Actually did have one question.
Sure.
So, like you mentioned, if you